Okay, today we need to discuss. This is our lecture 3. In our lecture 3, we'll go with magnetic field due to current carrying conductor part 2. Before that, what we'll do is we'll learn from basics once again. We'll see all the contents and then we'll get into the topic. So today's main agenda is to learn about magnetic field around current carrying conductor, current carrying conductor. Current carrying conductor, in the sense it is just straight line. We are talking about straight line wire or straight wire, we can say. Second, what about magnetic field around circular loop? Circular loop. What is circular loop? If you consider this is one conductor, this is A point and B end. If you catch those two ends and if you make it circle, I mean like this, like this circle one. So if you pass electricity through this circular loop, how about magnetic field? That we will see. And third one, multiple loops. Multiple loops, nothing but take a wire. You can make it as a spring. I think so you have some idea. So one end will be here and there will be n number of turnings, and this is, so this point might be B and this point might be A. If you pass electricity in between A and B, so how about magnetic field around this and this multiple loops or spring? We have to call it as solenoid. Name of that structure is solenoid. In this lecture we are going to cover, we are going to learn how magnetic field will be appeared when electricity is passed through straight wire, when electricity is passed through circular loop, when electricity is passed through solenoid. Okay, we know magnets are different types. There will be two poles for the magnet, north pole and south pole. Next, what we have learnt, if you take a magnet, around magnet there will be magnetic field and there will be two poles for the magnet. Around magnet there will be magnetic field. Inside magnetic field we can see magnetic field lines. Magnetic field lines by using some supplements like compass needle, or you can take iron fillings, etc. By using those you can observe. And few properties we have learnt in our last lecture. First, magnetic field lines are closed loops. So you can see if it is starting from north, it will move and it will move towards south. Again, what will happen? Inside, it will move towards north. Like that, there will be continuous circular flow. Second point, while coming to the direction of the magnetic field lines, if it is outside, magnetic field lines will flow from north pole to south pole, north to south. You can observe all magnetic field lines are starting from north and it will move towards south. And while coming to inside, magnetic field lines will flow from south to north like this. And third main important point we have learned, no two magnetic field lines touch. It will not intersect. There will be no intersection. That also we will see in this lecture with the help of diagrams. Next, if you take a bar magnet, if you place on a paper, or if you place paper on the bar magnet and if you sprinkle few iron fillings, automatically those iron fillings will be arranged themselves and you can see the pattern. Next, we have learnt, if you take a circuit, two circuits we are considering. First one, this one is open circuit. Second one is closed circuit. How can you say this one is open, that one is closed? You see here, switch is open, so it is open circuit. Here switch is closed, it is closed circuit. Now there is a circuit with the battery and switch. They kept one compass needle, and you can see direction. For example, if it is north, this would be south, this is east, this is west. Now if there is no power, if there is no current in the circuit, compass needle will show the direction of north and south only. That is default direction of a magnet. When switch is closed, current will pass. We know direction of current, that is from positive to negative, like this. This is the direction. When electricity is entering from the south, that we'll learn, the directions we'll learn. If a current is entering through south, means current is flowing from south to north, isn't it? South to north, there will be deflection towards west. That is so important. If current is flowing from south to north, compass needle will deflect towards west. If current is flowing from north to south, that compass needle will deflect towards east. In examination, they will not ask such type of questions, don't worry. If they ask, now you will be in position to answer it, isn't it? Okay. So this is the concept where we can learn, whenever you pass current through any conductor, automatically around this conductor magnetic field is produced. Magnetic field is produced. That is the concept we have learned. Next, while coming to this experiment, there will be two circuits. All equipments are same, but only difference is direction of battery. Here towards your left hand side there is positive, towards your right hand side there is negative terminal. But while coming to the second diagram, left hand side we have negative terminal, right hand side we have positive terminal. That is the only difference. Now if you place any compass needle near any side of the circuit, any limb of the circuit, first it will show south and north direction only, default direction south and north. Now if you switch it on, now current is flowing from positive and it is entering to south, isn't it? So here we learn, if current I, if it is flowing from south pole to north pole, now you see deflection. Here already we have learned, if it is flowing from south to north, deflection will be towards west. So current, if it is flowing from south to north, deflection will be towards west. You can see this compass needle will deflect like this towards west. Again, if you switch it off, what will happen? That will come to its original position only. It will deflect towards west. If you switch on, comes to original position. Next here, in the second case, electricity, now it is passing from this direction, isn't it? From positive, and it is entering from north to south. If current I flowing from north to south, there will be deflection towards east. You can find here deflection towards east. This point is important. Please remember and note it down in your running notes or classworks. These two. So from this experiment, what we can conclude? whenever you are passing current through conductor, around the conductor what is produced? Magnetic field is produced. If there is change in direction, definitely there will be change in magnetic field direction also. That is the concept we have learned from this experiment. And moving to next one, there is a simple circuit where one paper is arranged to one conductor. It is arranged here. Before switching on means when there is no current. So first remove that key, there will be no current. Sprinkle some iron fillings on the paper. You can observe those iron fillings will be random. Those iron fillings will be so random. Now, if you switch on, you are passing some amount of current through the conductor. Whenever you are passing current through conductor, automatically some field is produced, that is magnetic field. Magnetic field is represented with letter capital B. Please remember that. So from now onwards, current in the sense I will go with I. Magnetic field means I will go with B. So whenever you pass current through conductor, magnetic field is produced. And what is the shape? Here you can observe that shape is circular. And at the same time, if you place any compass needle here, you can see some deflection. Why magnetic compass will deflect? That is the question. We'll try to answer that question in this video, in this lecture. Okay, here we have learnt about right hand thumb rule. Right hand thumb rule. What is that right hand thumb rule? If you want to go with current, at the same time magnetic field around and in conductor, current in conductor, magnetic field around conductor. If you want to go with directions, most important direction, then right hand thumb rule will be used and applied. Consider this is one conductor. If you use your right hand, open your thumb, and if you close all your 4 fingers, if you wrinkle it, if you are holding that conductor, then this right hand thumb direction, what it is showing, that direction is representing current inside the conductor, and those wrinkled fingers, that is the direction which is showing regarding magnetic field. So if current is passing in this direction, magnetic field will be in this direction. So here you can observe, this is current I, magnetic field will be like this. That is a concept you need to understand. So around straight conductor, magnetic field will be in circular shape. And if they ask in examination regarding direction, this you can say, what is the direction? However you want, you can hold that conductor. That thumb will indicate direction of current. 4 fingers will indicate direction of magnetic field. There will be 2 directions. First one clockwise, second one anti-clockwise. So how? You see, this fellow is holding this conductor. First his fingers will be straight like this. Now he need to close. How he can close? in this direction, isn't it? So you can observe this is the magnetic field which is going in this direction. So here you can observe while you are holding it, you are bending your fingers in this direction, closing it. So magnetic field also will be in this direction only around the conductor. That's what you need to understand. Okay. Now the question is, when magnetic compass is placed near current carrying conductor, why you can observe deflection. So why you can observe deflection? So when magnetic compass is placed near current, okay, let us draw one small circuit. Consider there is a circuit with some key and there is some battery connected. Consider this is open circuit. Now let us place one conductor between these two, and if you insert a key, it will become closed circuit. Now you can draw direction of current. Now there is current inside this current carrying conductor which is in blue color. If you place one compass needle, so before switching on current, it will show north and south direction. Now if you switch on, it should deflect. Of course we know now it is flowing from north to south, it will deflect towards east, isn't it? East. Okay, my question is, when magnetic compass is placed near current carrying conductor, why you can observe deflection, or why deflection is observed? Why deflection is observed? That is the question we need to answer now. So to understand this topic, let us see one diagram, this one. You see there are two magnets. Of course you can consider this is rails here. This one is a magnet and this is full magnet here. I think so you all are familiar with magnetic field lines. Always magnetic field lines will start from north and it will travel towards south. Consider there is south here. This side is south. This side is south. Now like poles are facing each other. There is north and north. What will happen? Attraction or repulsion? Definitely there will be repulsion. Okay, let us understand that repulsion concept. You see, from north, one magnetic field line is passing like this. And of course, we know that magnetic field line will travel towards south. Here also, this also will travel towards south. All this magnetic field will travel towards south. Now, from this magnet, consider this is first magnet and this is second magnet. From second magnet also, we have magnetic field line which is emerging here and which is moving like this. And you see, it will not touch, just it will deviate like this. I told you, two magnetic field lines never intersect. If they intersect, what will happen? Okay, let us assume these two lines are intersecting now. Consider, which is moving like this one which is moving like this. Now What is this line? From where it is coming? From north it is coming. So entire this property is north. Here, of course, north. While coming to here, it is coming from north. And while coming to here, this is also emerging from north. While coming here, emerging from north. Here, north. While coming to here, this point of intersection, it is north. Where it is not possible, isn't it? If you take a magnet, consider this is north pole and this is south pole. If you break this magnet, what will happen? It will become two pieces, and this is first piece, this is second piece. If you cut any magnet, automatically poles will be rearranged. How? This side will be north as usual, this side will become south, and this side is south as usual, this side will become north. So if you cut magnet, automatically poles are arranged. And again you see, if you cut this magnet, what will happen? Again there will be one piece, there will be another piece. Now what about the poles? Of course, this side will be north, this side will be south, this side will be north, and this side will be south. Again, if you cut this, so how many pieces you want, you can make it. For every piece of magnet, there will be two poles definitely. There is no unit pole magnet. There is no unit pole magnet. It is highly impossible. We can't get. You see, this is a magnet with only north pole. This is the magnet with only south pole. No, we cannot get this. And no two magnetic field lines intersect. So this line will flow like this and it will go back to the south. This line will flow and it will go back to south. And here if you observe, consider this is a circuit where there is battery. Okay, don't get confused. I'll draw like this. Where there is battery which is connected to a key. It is closed circuit. There is current, isn't it? Now, if you place magnetic compass, there is compass inside that. And if you pass current, consider this conductor where there is current. Now, let me draw one diagram such that you can understand clearly. This is the conductor where magnetic field is produced. How about magnetic field, which will be in circular shape, isn't it? Circular shape, using right hand thumb rule. Now this red one, this is also a magnet. So when this is magnet, around magnet there will be magnetic field, isn't it? So this is north, this is south. From north to south there will be magnetic field, isn't it? Now you see, this red color is magnetic field of conductor. These black color lines, magnetic field of magnetic needle. Now there are lines intersecting, right? But lines will never intersect. Because of that, what will happen? This will deflect. Simple. Simply to say, there will be either attraction or repulsion. So simply to say, while you are passing current through this conductor is becoming magnet. If you observe compass needle, this compass needle is also magnet. If you bring two magnets near to each other, what will happen? Either attraction or repulsion. Simple concept. If you are passing electricity through conductor, conductor is becoming magnet. Compass needle means, of course, it is magnet. When magnets are brought to each other, then there will be attraction or repulsion, so that there will be deflection. Very simple concept to understand. You see, with the help of another diagram, we'll learn. You see, this is bar magnet, first diagram. This bar magnet, there is north pole and south pole. From north pole, magnetic field line will emerge, it will travel towards south, like this. If there is only single magnet, now if you have two magnets, there are two conditions again you can observe. This first condition, if you bring unlike poles, now you can observe there is north and there is south. From north, line will emerge, and of course, south is very near to each other. So what it will happen? Directly it will go and touch the south. It will emerge from north. South is very near to each other. Straight away it will go and touch the south, so that there will be attraction between these. And if two magnets, if it is attracting, what will happen? This is magnet and it is attracting to another magnet. This is you see same thing. This is north pole. This is south pole of first magnet. If you place north and south magnets, what will happen? Definitely north will move towards south. South will move towards north. There will be attraction. After attraction, here two magnetic lines are not intersecting. It is passing from one pole to another pole. Don't get confused. There is no intersection. Straight away from north, it is going to south. Of course, it will go like this also to south. Two directions are there. It will move from north to south in this direction. It will move from north to south in this direction. After that, both magnets will be attracted and it will become like this. North, here, south, north, south, north. And you see, south and north will become nullified. And simply to say, you can remove these poles. Simple. Now it will become one big huge magnet. Previously there was north here, south here, both north and south attracted. Now no magnetic line will flow from south to north directly inside, because distance is 0. If distance is 0, there is no flow, right? Then what will happen? Here I will write distance. Distance is 0. Now poles will be merged and it will become one huge magnet, and it behaves like single magnet. Again it will flow from north to south like this. That's it. So that is the thing you need to understand here. If you place two magnets of same poles, like poles, definitely there will be repulsion. How repulsion will occur? When two magnetic lines are not merging, not intersecting. There is no intersection, right? It will never intersect. So this north line will flow towards south. This one will flow towards south, like that. Both are separate. So there will be repulsion. This north will move far away. This north will move far away. So from this, I think so I have got, if you place two bar magnets near to each other, you see guys, now two lines are not intersecting. So definitely it must be like poles. Now what pole should come here? and what pole should come here? What pole should be here? What pole should be here? You need to guess. So two things. What you can say, here two lines are not intersecting. So this one and this one should be same poles. Second one, what is that pole? You see arrow marks, which is starting from here. So from which pole matic lines will start? Of course, this is north. So if it is north, definitely it will be north. From north also lines are flowing, and this will be south, this will be south. Like that you need to complete the diagram. So here one thing you need to understand regarding magnetic lines. Okay, while coming to magnetic lines, magnetic field lines, we need to talk about strength or potential or strength. So where there will be more strength, where there will be less strength, it is quite simple. If the lines are crowded means near to each other. So lines are crowded, there will be high potential. If there is huge gap between lines, that will indicate less potential. So if there is huge gap between lines, it is less potential. If lines are crowded, more potential. We'll see. You see here, while coming to this diagram, we'll go. First diagram. If you observe this diagram, you can say from north pole, while lines are coming out, here you can see very less gap between these two lines, right? Very less gap. And here also from south, you can observe very less gap between lines. So from this we can conclude one thing: near poles there will be huge strength. Near poles there will be huge strength. And while coming to here, you see there is huge gap. Huge gap is there here. So in the middle there will be less strength or less potential. That we can conclude here. You can see, guys, north pole, how many iron fillings are attracted here, especially this part, and you see this part, north pole, south pole. So there will be huge strength, huge potential at the pole, and in the middle there is no that much potential. Huge gaps you can observe. So that is the thing you need to understand from that. So where there will be huge strength, huge potential at pole and middle. Next, till now we have discussed about, so in the beginning of the lecture I told, in this lecture we are going to learn magnetic field around current carrying straight conductor. Second one, circular loop. Now let us see circular loop. Guys, this is circular loop. There are more diagrams you can analyze, you can learn. I'll explain each and everything. Consider this is the circular loop. So this is the point, and here is another point which is connected to circuit. Now this is circle. Whenever you can find circle, Around the conductor, definitely there will be magnetic field. That magnetic field will be in circular path, that we know. This side also we can say there will be circular path. Now, if distances are increasing, if distance is increasing, automatically that circle, those circles will enlarge. Circles will enlarge. Here you can observe in this diagram. Here we have one circle. Here circle is expanded. Here you can observe circumference still it is becoming more. Now this is one big circle. Now this is another big circle. Now this is another. So these lines are nothing but curves. Curve is nothing but part of circle, right? That is. So you are moving inside. If you are moving inside, if you are moving towards the center, if you are moving towards the center, circle will become a straight line. Simply to say, you are expanding the circle, you are expanding the circumference of the circle. Now this is big circle here, very big circle. So like that, if you are moving towards the center, at last it will become straight line. Here also you can observe, if you are moving towards center, these circles are expanding and at last it will become straight line in the middle. Same thing you can apply here. So you can apply right hand thumb rule. If current is in this direction, there will be magnetic field around the conductor. Yeah, magnetic field will be in circular shape. Now if you consider any one point, let us consider this is the point where magnetic field circles will be concentrated and at last it will become big. And if you are moving towards the center, it will become straight line. Same thing you can observe in all the directions. So in examination, if they ask, draw the diagram representing magnetic field around a circular loop. In these diagrams, any one you can draw. This is the diagram which you can find in your textbook. This also you can, if you want, you can draw it. So at edges, it will be in circular shape. If you are moving towards the center, if they ask you to explain this, you can say at edges, it will be circular. If you are moving towards the center, circles will expand and automatically it will become straight line. This one, right? So if you want to write as a theory, at edge, at edges, it will be in circular shape. If you are moving towards center, it will become straight line. So magnetic field will be in straight. Okay, whatever diagram you want, you can draw it. Single loop, at edge, it will be circle. Circles are expanding now. Circles are expanding, and it is becoming straight line. Again, if you are moving towards another edge, if you are moving towards another edge from the center, the circles will become again small and curves will become small and automatically it will become circular like that. So whatever diagram you want, you can write it. You can draw it. Sorry for that. So you can apply right hand thumb rule like this. So if you are taking a single point, at one point, you can see first there is a circle, next circle is expanded, next another circle is expanded. So like that it will expand, and at last it will become straight line in the center. Again, if you are moving from the center to the edge, those circles will become curve, and circles will become small, and you can get circle. That is the concept. And at last we need to learn about multiple loops. Multiple loops, nothing but n number of turns. N number of turns, it will be like spring structure. This you have to call it as solenoid. Solenoid. You see, solenoid will represent bar magnet, simple. If you know magnetic field around bar magnet, solenoid is equal to bar magnet. So you can observe the solenoid, which is like a spring structure. We have n number of turns, and if electricity is passed through the solenoid, you can observe. So this will become north, and if it is south, from north to south, magnetic field lines will flow, and simple like this. Middle will be straight. So middle, it is from south to north. It is flowing from north like that, and it will enter towards south. So solenoid is exact replica of bar magnet, guys. Here also you can observe. So solenoid and bar magnet, both fields are same. If you want for bar magnet, you can draw middle also like this, and you can represent direction from south to north like this. So here, while coming to the direction, if current is entering, that point will become, I mean this plus, this positive terminal, it will produce south pole, and negative will have north pole. Very easy to understand. If it is negative, you can get north pole. So negative starting with n, north pole starting with n, like that you can remember. So negative terminal, that side please represent north pole. If it is positive terminal, please represent south pole. Electricity will pass, and that current will pass, and it will come out from the north, and easily you can draw. So whenever in examination, if they ask you to draw solenoid like this. So first, solenoid with n number of turns, and you can extend that line down. And if you are representing this one as negative, this one as positive, negative we have north pole, positive we have south pole, and you can draw magnetic field lines. You are very familiar with that, north to south. And you can extend like this. This side you can extend, another line extend, and middle, that should be straight. Arrow marks are so important. North to south, north to south, north to south, from north, here north to south, north to south, north to south, to south, to south, to south. That's it. So in this lecture, we have studied about all these things. So in our next lecture, we'll see force acting on conductor because of magnetic field. So that's it in this lecture.